everyone, this is the continuation of my other video about nodal analysis. I'm gonna be talking about nodal analysis for circuits with voltage sources. What's the difference? Let me give you an example. Here, let's say we have one node called V1 and then we have a voltage source. Let's call this voltage source V. Let's say it has V voltage. And we have another node in here which is called V2. Here, what do we call this? When we have two different nodes and we have a voltage source in between, we call this whole thing a super node. It's a very important thing when we're solving circuits with voltage sources. What do we get out of this voltage source? We say that voltage on the positive side minus voltage on the negative side is equal to the voltage in our source, which means V2 minus V1, positive side, negative side, is equal to V. As you remember, even in the previous questions when we were solving and when we didn't know our current, we would say, let's say V2 minus V1 over our resistance in between, it would be our current. Why would we say that? Because we would say this current minus that current would be the voltage in between, and then we had the resistance, and then we would divide them and it would give us our current. Here, maybe you will ask, why not V1 minus V2? If we do that, if we say V1 minus V2, it wouldn't be equal to V anymore, it would be equal to minus V, because our current would be coming out of our negative side. So our voltage would be negative. So that's the only difference here. And even in here, if we multiply both sides by negative, it's still gonna be the same thing. So basically there's no difference. So what we say that voltage on the positive side minus voltage on the negative side is our voltage source, the amount of voltage in our voltage source. This is a very important thing we need to know before we start to solve our examples. Again, my first example, I'm just gonna be having no numbers and no calculations. I'm just gonna show you guys how we derive the calculation when we have a super node. Here you see we have our voltage source. No number, so we can name it V. We have our resistances, and we have also two independent current sources. So here, first things first, we're gonna recognize our super node. We say we have a voltage source and it's in between two of our main nodes, two of our only nodes in here, and we call this whole thing a super node. What happens when we have a super node? When we have a super node, we're not gonna be going through our nodes each one by one. Not gonna be like node 1 and then all the currents that going to node 1 and node 2, all the currents that going to node 2 are equal to 0. We're gonna consider the whole super node as a whole together, and we're gonna sum up all the currents that going and coming from this whole super node, this whole line in here. All the currents go in here and all the currents are going here, and then sum them up, and that's gonna be equal to 0. Here, when we want to write, first of all, we said that when we have this super node, we say voltage on the positive side minus voltage on the negative side is gonna be the voltage in between. So already we have an equation, our first equation, because as you can see here, we have two variables, V1 and V2. So we have two equations, we can solve this easily. So how do we get our second equation? We say, instead of saying node 1 or node 2, we say super node 1, 2 in here. And we're gonna be writing down all the currents and then equal them to 0. But one thing here is very important, you need to know. Here, as you can see, there is a current going to this wire, this branch. As you can see, the current is same throughout the whole branch, and the current that's coming out from here, it's gonna be going through here. Even if we say the direction is reverse, if it's coming out of here, it's gonna go here. So it's gonna be the same current, once going in, once going out. It's gonna be like we say I minus I. It would be 0. So we cannot totally not consider this branch, because the current which this branch is giving to this supernode, it's getting from it, so it's actually going to be equal to 0. So there is no point of writing it down. What we do here, so we don't consider this branch, and we say we start from our first node in our supernode. We say we have a current here going to this supernode, which called I1, which is going to the node and not coming out. So we have a minus before I1. And then what do we say is that we have another current here. Here I forgot to write down, it's the earth, so the V here is 0. So also the V here is 0, V here is 0. Voltage, all these points are 0 because there is no resistance, nothing in between. So all the voltages in here are going to be equal to 0. So here we say this current, if we consider the direction this side, so we can put a plus in here. We say V1 minus V here, that is 0, over R3. And then we're going to our second node and see if there is any current going or coming from this node, going to our whole supernode. We said we don't consider this branch, so we say here, okay, we have a current coming out, which makes it a plus I2. We have another one in here, again like the previous one, we say plus because we consider it like this, the direction, V2 minus 0, which our voltage in here is 0, over our resistance, which is R2. This whole thing is equal to 0 because we wrote all the branches that's sending or getting current from our supernode. So if we say that these zeros are going to be cancelled because they have nothing in here, like they have no value. And then we say, so this gives us V1 over R3 plus V2 over R2. If we take our currents to the other side, it's going to be I1 minus I2. And this is going to be our second equation. We have two different variables, V1 and V2. And if it was a real question with number, we would have the value of our voltage source, we would have the value of our current sources, and we could easily solve this question. The other example I'm going to be solving is a little bit difficult. It's going to have a lot of calculations and a little bit different than what we solved before, with two different voltage sources. It has a lot of variables, so it will take me a while until I draw it. As you can see here, we have a Vx, which I'm going to explain shortly. If you remember, in the previous video, I solved the question which we had Ix, and we had a dependent current source. Here we have a Vx, and sorry, this is 3Vx. Here we have Vx and a dependent voltage source. So what do we do when we see that? I'm going to be explaining to you. Okay, what do we want? We want V1, V2, V3, V4. That's our question. We want to solve this. First things first, we have two different voltage sources, which both they have two different nodes at the beginning and then at the end of their branch. So we actually have two super nodes. Why? Because we have node 1, node 2, and then voltage source in between. We have not 3, not 4, we have a voltage source in between. It doesn't matter if their voltage sources are dependent or independent, it's still a supernode. It may make our work a little bit more difficult, which it's not actually that difficult, but still, but it doesn't really matter, it's still a supernode. So here, what do we do first? We first try to write the equation inside the supernodes. So what do we say here? We said the voltage on the plus side of our voltage, the node on the plus side of our voltage source, which is V1, minus the voltage on the negative side, which is V2, is equal to our voltage source, which is 10. So we have one first question. We have 4 different variables here, guys. So the most important things that we first see it, and we first know that we have to have 4 different equations with these variables in order to solve all these 4 variables. And then we have another supernode in here, which again the same thing. We're gonna write V3, which is the voltage on the positive side, minus V4, which is the voltage on the negative side, is equal to the voltage in between, which is 3Vx. But what is Vx? Here we have Vx again. Here, guys, we don't consider that we have like a resistance here. It doesn't matter. We have it. We have a resistance here, but we know that our V in here is Vx. So, and we know that if we say the voltage from the positive side minus the voltage on the negative side, which is V1 minus V4, it's gonna be this voltage in between. So it's Vx. So how do we solve this? Now we can drive one equation out of these two. We need to omit Vx in order to just have V1, V4, V3, because we want to write an equation with these 4 different variables to have our second equation, and then we would need only 2 more equations. Here, what do? We substitute Vx with V1 minus V4 in here. So we say V3 minus V4 is equal to 3 times V1 minus V4, as easily as that. This is equal to 3V1 minus 3V4. Then if we take everything to one side, we're gonna have minus 3V1. This is gonna be plus 3V4, which is plus 3V4, plus V3 is equal to 0. Let me say if I did this right. Yeah, this is minus in here, this is plus. Yes, I did it right. So this is our second equation. We need 2 more equations, and how do we get them? We write the equations for supernode, 1, 2, and supernode 3, 4. We have 2 supernodes that we can have 2 different equations from them. Supernode 1, 2, here, as you remember in the previous example, the branch was coming like this. So the current that we're going and coming back, it would be the same current. But here, the current here is not the same with this current here, and this current, like the same current, is coming to somewhere else. So it doesn't, we have to consider this branch. It's not like previous example that we say we don't consider this branch. So we consider it. So here we start with this one. We say we want the current in here that is going, we want the current in this direction. So we say V1 minus V4 over 3, which is our resistance. And then we want the current here in this direction. We know this one V is 0, here V is 0. So we say plus, because current is in this direction, V1 minus 0 over 2, which is our resistance. And then we're done with this part of the supernode. The other side, which is here, it gives us plus, if we consider the current in this direction, this branch, we say V2 minus V3 over our resistance, which is 3. And here we have the current already, and it's going through the node, so we need a minus here, and we say minus 5. The whole thing is equal to 0. To make this easier, We multiply the whole thing by 6 to omit our denominator, which gives us 2v1 minus 2v4 plus 3v1, this is cancelled, plus 2v2 minus 2v3 minus 30 is equal to 0. If we take 30 to one side and then sum this up, it's gonna give us 5v1 plus 2v2 minus 2v3 minus 2v4 is equal to 30. Our third equation. And then we want the fourth equation, which we get it from the supernode 3, 4. What the supernode 3, 4 gives us. We start from here. We have a current here. This time, for this node, we will consider it in this direction. For this node, we're considering in this direction. So we say plus v3 minus v2 over 3. Here again, we consider it in this direction. So plus v3, v is equal to 0, v is equal to 0 here, minus 0 over our resistance, which is 4. Then it's a supernode, so from here, this our current, we consider this current, so it gives us plus v4 minus v1 over 3, which is our resistance, and here we know that this v is 0 again, and then we consider this one, so make it this plus in here, so we say v4 minus 0 over 1 is equal to 0. So to make this easier, we multiply it by 12. And what it gives us is 4v3 minus 4v2 plus 3v3 plus 4v4 minus 4v1 plus 12v4 gives us 0. We sum this up, it gives us minus 4v1 minus 4v2 plus 7v3 plus 16v4 is equal to 0. These are 4 equations. We have 4 variables we need to find. We have 4 different equations. And the most important part in this questions is to find the equation. Once find that, it's all just a mathematical problem. It's just a matter of knowing mathematics or not, which we should know by this time that we're doing circuits. We should have the knowledge, enough knowledge of mathematics. What do we do here? We can do matrices, which we have to mostly calculate it with hand, or what we can do that here it's very easy to do is to, for example, I say I'm gonna cancel my variable to v2 from these 3 equations. I'm gonna have 3 different equations with 3 different variables, and then I'm gonna find those in my calculator with matrices, and then according to that, according to v1, because I'm gonna be writing v2 according to v1, I'm gonna find v2 at the end. What I'm gonna do right now, I'm gonna say v2, I'm gonna take v2 to this side and bring 10 to the other side, v1 minus 10. So what I'm gonna do, I'm gonna put v2 in all these equations. Instead of v2, I put v1 minus 10, and I'm going to be writing 3 different equations with 3 different variables. Here we don't even have a v2, so I'm just going to be writing the same thing, minus 3v1 plus v4 plus let me write it. I want to write them v1, v3, v4, so we won't be confused. Minus 3v1 plus v3 plus 3v4 is equal to 0, our first equation. Here I'm gonna be putting v1 minus 10 instead of v2 in here, which will give us 7v1 plus 2v2 minus, sorry. It's okay, let me just write it down in here first and then rewrite it there. Say 5v1 plus 2v1 minus 20 minus 2v3 minus 2v4 is equal to 30. So this gives us 7v1 minus 2v3 minus 2v4 is giving us, I'm taking minus 20 to the other side, 50. So I'm gonna write that here. 7v1 minus 2v3 minus 2v4 is equal to 50. This is gonna be my second equation. And the third one is coming from here, which first I'm gonna be calculating it in here. Let's say minus 4v1 minus 4v1 plus 40. I'm substituting this one instead of v2, plus 7v3 plus 16v4 is 0. So what it gives me, that minus 8v1 plus 7v3 plus 16v4 is equal to minus 40. So here I'm writing this equation here, so we know that our third equation is minus 8v1 plus 7v3 plus 16v4 is equal to minus 40. Then I'm going to be writing matrices according to these three equations that we have. So our matrices is going to be like minus 3, 1, 3, 7, minus 2, minus 2, minus 8, 7, 16. And then we're going to have V1, V3, and V4. Then we're going to make them equal to 0, 50, minus 40. So I'm going to be calculating this with my calculator. I'm going to show you guys in this video how I'm doing it with my calculator. So I'm going to press my mode. I'm going to press the equation mode, and I have three different variables here. So I need to select the second one, and then I just put my numbers here according to what it is in here. Minus 3, 1, 3, 0. I'll just put each number and then press equal after it. 7, minus 2, minus 2, 50, minus 8, 7, 16, and minus 40. And then each variable x is gonna be our v1 in here, which is 1.58. Our v2 is gonna be our y, which is 31.58, and our, sorry, this is v3 because here we have v3, and our v4 it's gonna be 12.11. So how do we find our v2? We said v2 is equal to v1 minus 10. We had this equation. That's how we substitute this instead of v2, and we found our three equations. So here v1 is 1.58 minus 10. So our v2 gives us v2 minus 8.42 volt. That's our